Awesome. All right. So before we get into anything new today, I wanted to have you take a few minutes and look at the solutions that I posted for homework 4.5b from yesterday. If you jump onto Canvas, which is what I'm doing down here, and look at today's announcement. Hopefully it came through. Let's see. Yeah, at the bottom, you've got answers to number 1. Number 2, which is right behind me, which I wanted to leave up just so we could talk about that. And then 3 through 6 are in that last picture. So take a couple minutes, see how you did, and ask me questions if you have any. This is kind of the last time that we'll play around with this before we review for any chapter 4 test that we'll take, whether that'll be remote or in person, kind of depends on timing. I'm leaning more towards like the end of next week sometime, right, because today's Wednesday. Yeah, like middle or end of next week, something like that. So my guess is that it'll happen remotely, which means you'll have, notes you can use and you can look back at all that good stuff. So having good answers to the work that you did, instead of having to like look up my answers, I think is going to help you out a lot too. So plus it might help you figure out why you made a mistake in case you did. So take a look. I'll let you do that for a couple minutes. Let's get back together at 8:35. I will kind of reconvene us and we'll talk about it. Okay, so do that first. And if you have a question, just shout it out. When you do get to number 4 and number 6, your choice for C over B is kind of up to you. I think there were a couple good choices for number 4 and a lot of good choices for number 6 as to where you wanted to start. I like to always start as close to the origin as I can, right? So that's why for number 4, when you get there, you'll see that my starting point, I put on the y-axis, right? I picked that one instead of the one to the right or the one to the left. That would have been fine. So if you picked a different C over B and your equation matches that, then great. And those are the kind of things, 3 through 6, where if you're, given a graph and you want to come up with the equation and you get yourself to an answer, then like plug that equation in and see if the graph that you see on your calculator, or if you jump onto like Desmos.com, plug it in and see what it looks like and compare the two. And if they look the same, then you know you did it right. If something's off, then you know you got to fix something. So I'm a really big fan, especially in Desmos, because it happens really quickly and you can like click on maxima and minima to make sure that what you think you've got is actually what you've got. You have to adjust your scale though in settings. It looks like a little wrench. If you're in Desmos, top right-hand corner, I think there's a wrench that allows you to kind of pick your scale and pick your steps, pick your window, kind of like you would on a graphic calculator. still see some people working a little bit, so I'll give you another minute or two. While you work, though, I'm going to talk a little bit about number 2. So if number 2 is something that you struggled with, it's kind of why I picked this one. When you've got a period like 4 pi, that's the space we've got, right? So the most we'll ever see is 1 full cycle. And in this case, where we have a starting point over at negative 3 pi over 2, I'm never going to be able to make it all the way back up to the maximum, or if it was sine, get back to that midline. And that's okay, right? And so what I did is I just kind of followed those steps that I wrote down yesterday and how to find the points, right? So I wrote that down here at the bottom. I started with my starting point, and I went to the end, and then I cut that in half to find the middle, and then I found points 2 and 4 by cutting those spaces in half. But I can only plot 4 of those 5 points, and that's okay, right? And so when I went through this graph, right, I just kind of started here, and I went down. Right, I started at the points that I had, and I just kind of connected those. And then I said, well, let me just keep going as much as I can. I know I'm not going to be able to get all the way back up because, 5 pi over 2 is over there. I just kind of aimed for it by continuing that flow up towards y equals 0, that maximum spot, but I knew I wasn't going to actually get there. Same thing, I know I'm not actually going to get back down to the midline at negative 2, but I just kind of take a turn and I head back down. As best I can, right? When you have those frequencies that are smaller than 1, and this graph gets really stretched out horizontally, it can be a little bit trickier because you want to plot all 5 of those points and connect it and see that full cycle, but that might not happen, okay? And that's okay. But that's why I wanted to put this one on here for us to kind of play around, okay? Number 1 was a little bit easier. We just plotted some nice points, and we were able to just kind of fill in 1 full cycle and then copy it to the right and copy it to the left, just kind of going with that nice up and down. So hopefully you did okay with that. Any questions on anything? You might feel like you don't have it completely down just yet. That's okay. I promise that we will have some time to review. If and when we do take this test, I'll make sure we get at least a day of review in so you can come back to stuff like this. The chapter 4 test that we will eventually take will not go back to anything from last semester. It will start with this semester. So you don't have to worry about going all the way back. Which will leave out a couple things, but that's okay. Last semester was a long time ago, so I'll make sure that I create a study guide and kind of give you the topics laid out as to whatever that's going to look like whenever we get there. Okay. All right. Super fast. What I'd like to do, because I know we're a little bit shorter on time, and I want to talk about classes for next year, and I didn't want to do that now because seniors don't really need to stick around for that, so you guys could get out of here. Let's see. What time are we done? So it was 8:30, so 9:15. Okay, so we got a little bit of time. I'm gonna get rid of all this. I want to graph just the parent function versions, so no transformations, of the other 4 trig functions: tangent, and then the reciprocal ones, cosecant, secant, and cotangent. Okay, so take out your blank trig graphs. You're going to need 4. I'm just going to do them all separately. It's just easier to kind of see them in that space. And what I've got on my laptop down there is I've got all of those 4 functions plugged in already. And I've got my table set up in a way where I can look at points at every single x value, every single theta value that runs from left to right. So that I'm not guessing my way through, and I'm not really spending a ton of time actually taking the reciprocal. Hey, I know that it's radical 2 over 2 at 45 degrees for cosine. Well, I'm going to flip that, and I'm going to do all the arithmetic. No, I want to kind of just show you why this stuff works the way that it does. And kind of give you just a nice basis to have to be able to look back at should we ever need it. In my experience with teaching trig and with also kind of being at the mercy of CU, by the way, you just have a couple of weeks left to sign up. I think registration closes the end of the first week of February. So I think it's like February 4th or 5th. So make sure you sign up for that if you're interested in getting the college credit for that. But let's do it. So I'm gonna, on my side, I'm not gonna actually share my screen with you necessarily, but what I've got in my graphing calculator, and you can do it right in your graphing calculator, or you can do it on Desmos. I've got tangent plugged in, and I've got cosecant, but there's no cosecant button, so I just have 1 over sine of x, or theta, right? For secant, 1 over cosine, and for cotangent, 1 over tangent. That's the only way to really do it in the graphing calculator. Same thing, I think, on Desmos. I don't know if they have all 6, or if you just have to type in just 1 over to get you that reciprocal. And we're just going to work our way from left to right, plotting points and kind of talking about what happens along the way, remembering a couple things. And we'll just go one by one by one. Okay, so you don't necessarily need any colors here because we're just going to graph one function at a time. And I'm just really relying on my table in my calculator to help guide me, and I'll explain where these numbers come from as best I can while I do it, okay? So whatever graph you happen to be on, call it whatever you'd like. You know, I don't know if we're on graph 10, 11, 12, 13 at this point. And everybody does it a little bit different, so I don't really care which one you're on as long as you've got a blank spot. Let's do tangent first. So y equals tangent of theta. And be okay with them calling it tangent of x too. That's going to happen sometimes, especially, I mean, they're x-axis, right? So that's fine. I know we like to use theta because I know it's definitely an angle, but sometimes they'll just use x, okay? And what I'm going to do is I'm going to go left to right. But what I want to remind you of is that when we're dealing with tangent, remember that that's sine over cosine, okay? And that's where all of these numbers that I'm going to get are really going to come from, okay? That this is what, now, I really shouldn't write y over x. It's a little misleading. But when you think, I'm going to put it like way over here. It's not really equal to, because y and x, whatever. But it's the y values from the unit circle over the x values at those spots along the way. Okay. And so what I want you to think about as we graph these is that, right? That we're really just thinking about y over x at those spots. It's sine over cosine, and that's really what tangent is. Okay. And so when I get to a spot like negative pi over 2, it's really just, I'm going from 0 to 2 pi. I'm just going to start over here. I'm going to go 0 to 2 pi, which is the same thing as going from negative 2 pi to 0, right? We're starting at the beginning and just kind of working our way left. Let's make every box worth 1, okay, up and down. Because we will be, you know, taking numbers like 1/2 and dividing them by 1. You know, there's a lot of things that are going to happen here. So as best I can, I want to talk through this without taking too much time so that you can really just kind of get the hang of what these graphs are going to be. Okay. Okay, so imagine starting at 0, right? That's where we're at. Okay, so I'm at the point 0, 1. So maybe having your unit circle nearby might come in handy as to just kind of finding those numbers quickly. When I'm at 0 radians or negative 2 pi radians, and I think about y over x, right? The y value at that spot is 0. The x value at that spot is 1, right? Because I'm at the point 1 comma 0. 0 divided by 1 is 0, and I've got a point. Okay. Now I open up an angle, and I'm just going to stop at my 45s and my 90s. 135, 180. I'm not going to stop at the pi over 3s and pi over 6s, although I could. It just would take even longer to do. When you stop at 45 degrees, when you stop at pi over 4 or negative whatever that is, 7 pi over 4, the y and the x value are the exact same, right? And so divide one number by itself as long as that number is not 0, and we're going to get 1. So I got a point right here. Okay. But then we get up to the top. When I get up to this point up here at the top, where I'm at 0 comma 1, and so what I've got for y over x is 1 over 0, right? And what we see is that I don't get an answer back for that, right? And my function is undefined at that spot. And remember that there's only really 2 options for graphing when things are undefined. If it was 0 over 0, we'd have a hole, right? Like we did when we were dealing with rational functions. But if it's anything else, over 0, right? 1 over 0, 5 over 0, negative 6 over 0, whatever it is. What happens graphically with rationals is exactly the same thing that happens here. I mean, there's a rational function for us, just a trigonometric rational one. We get a vertical asymptote. Okay, which means we are going to be headed either up towards the arrow at the top or down towards the arrow on the bottom. And so what I want you to think about as like what would happen as we got closer to that point, as we move, once we do this once, you should be able to kind of get the sense of how this is going to work. As you move from 45 degrees up to 90, as you move from pi over 4 to pi over 2, what's happening is the y values are getting bigger, right? Not really big, but they're going from, radical 2 over 2 up to 1, right? So you're getting bigger on top. The top of your fraction is getting bigger. But what's happening with the x values is they're getting smaller, right? I'm going from radical 2 over 2 for the x value, and I'm moving towards 0. And so when you think about what's happening to this fraction, the top of the fraction is getting bigger, it's moving towards 1. The bottom of the fraction is getting smaller, it's moving towards 0, and the signs are the same in that space, right? Because we're just in the first quadrant, x and y are the same sign. And so dividing things that are the same sign, we're just going to get some positive number. So that's good that we're up here, right? But what happens to a fraction when the top starts to get bigger and the bottom starts to get smaller is that fraction gets larger and larger and larger, right? The actual decimal that goes with that fraction heads towards a positive infinity. And you would see that as if we stopped at something like pi over 3, you would be at, all right, y value radical 3 over 2 over the x value 1/2. The 2's would cancel from the denominator. You have radical 3 over 1. Okay, that's a square root of 3. That's like 1.7. Right? When our numbers start to get bigger and bigger and bigger. And so what happens is we're going to be headed up towards this arrow at the top. And so what I'm going to do is I'm going to put my arrow next to that little arrow as kind of a guide. I don't know if you remember when we did that, working with rationals, we gave ourselves something to aim for later on, right? So this graph is going to head up in that direction. And hey, let's connect it right now. We've got just 2 points and the arrow. So let's just kind of connect it like that, kind of like we would with a rational function, kind of smooth and curvy, no straight lines there. Up we go, okay? Hopefully that works okay for you. Sweet. All right, now let's keep going. So let's get ourselves into the second quadrant at 3 pi over 4, which in this case is negative 5 pi over 4. Same spot. It's just going to repeat. And when we're there, it's, we're on the other side of the y-axis. So x is negative, but y is still positive. And so when I divide y and x, I'm going to get a negative number back. But when you're at 135 degrees, when you're at that 3 pi over 4, the x and the y value are the same, right? Negative radical 2 over 2 on top and positive radical 2 over 2 on the bottom. Divide two numbers that are the same by themselves, or divide them, get 1. And in this case, we just get negative. So I've got a negative number right there at negative 1. Okay, cool. So that's pi over 4, pi over 2, 3 pi over 4. All right, now we're at pi, which is the same as negative pi, right? Just opening up or down. And so I'm back here, over here, where my y value is 0, and my x value is negative 1. 0 over negative 1 is 0. So at negative pi, we've got a point 0. Keep going. We get ourselves to 5 pi over 4, right down at the bottom, negative 3 pi over 4. And now we're back to that 45-degree multiple where I know the x's and the y's are the same. I have to watch my signs, right? And in the third quadrant, x and y are both negative. And when you divide two negatives, you get back to being positive. It's the same number divided by itself, so you get 1, positive 1. And then you get yourself to negative pi over 2, so 3 pi over 2, down there at the bottom. And we kind of have the same thing that we did up top, right? Because x is 0, right, when you're on the y-axis, and so you're dividing by 0. Which means if I'm dividing by 0, and now I've just got a negative 1 up top, not a 0 over 0, so no holes, but a negative 1 over 0, I've got another vertical asymptote. The negative pi over 2, we've got this vertical asymptote, okay? Which means we have to head towards this vertical asymptote, and we have to also head towards this one here on the left, right? Remember, we have arrows kind of on both sides, and you can see kind of the trend that's going to happen. As I read this from left to right, I'm going up, so there's my arrow on the positive side of things when we get to negative pi over 2. And as you read this from right to left, down we go, and we've got an arrow down here, okay? And what you would see if we plotted a whole bunch more points in between is that although these three are kind of in a straight line, it's really more smooth and curved, just like we've been doing all of these graphs, right? They're all pretty smooth and curvy. And so when I connect this arrow to this one, watch how I do it. Take a look before you actually do it. I'm going to get myself to this point, but Then I'm going to approach the x-axis a little bit early, flatten out and turn, and then head up. Okay, kind of like we did with cubics. Okay, that's kind of the flow of this graph. Is it's got that kind of x cubed flexing that happens at that spot. Okay, and you can see that the entire section of this graph between -3π/2 and -π/2 goes all the way from -infinity to infinity in terms of your y values. It covers everything, right? And what you're going to see is that is just going to repeat. Okay, I'll talk through this one more time, and then we're just going to copy it over. At -π/4, which is 7π/4, you're back to that 45-degree reference angle. So your x and y values are the same. Just have to watch my signs. I'm in the fourth quadrant, so right, because I'm just going down at π/4, sorry, where y is negative, but x is back to being positive. Divide them, I just get -1. And then I'm back to the start, right? And so now I can just copy this over. -2π is the same as 0, so I got a point at 0. And then 1, and then asterisk. And what you'll see is this progression just continues. -1, 0, 1, asterisk. -1, 0, and then I'm at a space, okay? And so I can put the arrow down here, the arrow up here, in between my asymptotes, come up to this point, flex like I would a cubic, and then head up. Arrow down here, arrow up there. Come up to this point, flex like I would a cubic, head up, arrow right here, keep going. And you can see how it would kind of like connect. If this graph would keep going, this could be sitting right over here, and it just repeats. Okay, and so what I want to start doing is talking a little bit about domain and range for all these functions too as we go. So I'm going to come off on the side here and write that down. Okay, when we talk about the domain of this function, the issue that we've got is that we've got these repeating vertical asymptotes that keep happening at things like π/2 and 3π/2. 5π/2 and 7π/2 and 9π/2, forever going that way and forever going this way, right? -π/2, -3π/2, and so on. So I'm going to give you the domain here in a second. The range is a whole lot easier because every y value could show up, right? So we've got all real numbers, right? We've got from -infinity all the way to infinity. We can do that. But when you talk about the domain of a cyclical function that just kind of repeats, what we see that we kind of run into is like, how do I say, okay, don't use π/2, and don't use 3π/2, and don't use 5π/2, and don't use 7π/2, and don't use 9π/2, and don't use -π/2, and -3π/2, and -5π/2, but use everything else, right? And what we found is that sometimes it's easier to say all of the points that don't work rather than listing all of the points that do, right? We just have to say a lot of points here, okay? And so here's how we're going to say that, okay? X cannot be equal to, of course, because we're going to list the points that don't work rather than the points that do. But I want to say like π/2 and 3π/2 and 5π/2 and 7π/2, and all of those multiples of what happens when I start at something like π/2 and I add pi to it. And I add pi to it, and I add pi to it, and I add pi to it. And so here's what that looks like. Okay, all of the x's that aren't π/2 and then plus multiples of pi, right? Because from π/2 to 3π/2, that distance is 2π/2, which is just pi. And so I'm going to call that n pi. Then I'm going to add a little something to it right below it or off on the side. I'm going to stick with the white. Okay, so I'm going to put a comma right here, and I would keep going. Box that off right there. Because I have to tell whoever's reading this whatever n is, where n is a member of the integers, right? Because I just want multiples of like 1 pi or 2 pi or 3 pi. And so that's a capital I with 2 lines going down. Kind of like the real numbers was a capital R with 2 lines going down. Same thing for the integers, okay, capital Pi. Right? And if that doesn't quite sink in yet, that's okay. I mean, just think about it. Like pi over 2 is not going to work. And if I just add a 1 pi or a 2 pi or a negative pi or a negative 2 pi, I keep running into those vertical asymptotes. Okay? And so the thing that makes this one a little different than sine and cosine, I guess there's a few things that make it different. Obviously, we've got some spots where we're not going to get answers back. Our domain is not all real numbers like it was for sine and cosine. We've got spots along the way where we have to stop and say, no, I don't have a point there. I've got a vertical asymptote instead. So our domain is broken apart. But it also, we've got a different looking period as well, right? How long it takes to get through one full cycle doesn't take me all of 2 pi, right? It doesn't take me all of 2 pi. It doesn't take me all of 2 pi. It actually takes me only half of that. The period for tangent is just pi. Because when you work your way from the first quadrant into the second and you just kind of finish that route, it takes you into both combinations between where the sine of x and y are the same and where the sine of x and y are different, right? And then when you get to the third quadrant, it does it again, right? Because the sines are the same. And then the sines are different in the fourth. All right, so there's tangent for you, okay? All right, talk to me. Questions about that? Because I know that graph is totally different. Is that okay? You feel good about that? Give me something so I know that you're up. Is that all right? Have you seen that one before, or was that brand new? You have seen it before. Okay, good. So good. A little quick refresher. Well, maybe not super quick, but maybe you hadn't heard like that setup for the domain or talked about that period as much. So I wanted to make sure that we did that. Okay, cool. That's the one that I wanted to really just focus on today. We will do the other 3 tomorrow. I wanted to stop for a second today and talk about classes for next year, especially since this is the shorter day with that homeroom that shows up, because we're out of here in about 15 minutes. I don't know that I'll need 15 minutes to talk about things, but what I wanted to do was give you a chance to hear from me about what I think about your choices for next year, and maybe start making your first unofficial choice. Super unofficial. Nothing about what you are saying right now is something I'm going to hold you to, but I want to kind of see where you as individuals, but also you as a group are at. So you can stop with your graphs for now. We're going to stop with trig. And I want to talk about next year. Now, seniors, you don't obviously need to be here for this, but if you look on Canvas, and this goes actually for everybody, seniors and everybody else, go back to Canvas, go to today's announcement. So sophomores and juniors, there's a link that says the 21-22 math course request form, unofficial. Open that up. And seniors right below that, obviously you can skip that part, but I did include a form for you guys in case you are interested in sharing with me your thoughts about after graduation, kind of how you're feeling about dealing with being a second semester senior. Maybe if you have questions or you want some advice. You don't really know me all that well, but I've done a lot of different things in my life. I took a year off after high school, and I spent 3 months in Germany and 6 weeks in Georgia working for Habitat for Humanity when I was in Georgia. I played college sports. I worked full-time jobs. I got internships and temporary jobs, and kind of traveled the country, and I've done a lot of different things. So I've got lots of stories that I could share with you and impart maybe some knowledge that might be helpful. One of my favorite things about teaching is helping a group like this figure out what they want to do next. And not just next year, but beyond that. So, and we've got a great, post-grad department. Miss Murphy is amazing at helping guide you. But I would love to help you as well. So if that's something that you want to do, seniors, it is completely optional. There's a form right there that says fill out this form. It's clickable. If you want to do that, great. If you don't, that's okay. But seniors, you don't have to stick around for this. You guys can log off. I will see you tomorrow. Nothing you need to do before then. Or you can stick around if you want. But that form is there for seniors. For everybody else, have that 21-22 course form open. And you can make your unofficial selection today if you have probably like a first choice that you think you want. But don't fill it out until I talk about it here for a quick second. That's what I'm going to do. There is a spot. Let me go back to my questions here. I'm going to share my screen so I can point at stuff instead of you looking at this. And I want to answer any questions that you have, but I want to tell you my side of things first, hopefully, to maybe help kind of guide you. Okay, what we did and what we've done every year is we create this typical pathways kind of visual organizer to help you see what you're heading towards, okay, potentially. And so what you'll see is that we are right here, right now, okay? And that there are a couple different directions that you can go, okay? If you are a sophomore and you are in one of these classes, you basically have just a couple choices, okay? You could go to AP Calc BC, which is the hardest math class that we offer. It is the most rigorous. It is the most challenging intellectually. It really kind of pushes you to explore calculus quickly, but also in depth, okay? Our plan usually is to only have one section of that, okay? That is for the group that has felt like everything up to this point and including this year has been easy so far, okay? Because the jump from Calc A to Calc BC is even a relatively big one as well. It's not the kind of thing where, you haven't even seen calculus yet. But if you've been really comfortable with what we've been doing so far, then you will probably continue to feel comfortable in calculus, even though that stuff is going to be pretty new. And I know that we're making this choice before you've even seen calculus, and that's okay. So if you are thinking BC, basically you definitely should have scored an A as your semester grade last semester, but basically gotten an A on everything. You have an A homework average, you have an A test average, you got an A on the final. Things have been easy. You have a great work ethic, and you are headed in a direction after high school in a mathematics direction or an engineering direction or maybe a science direction where calculus is going to be part of your course load in college, that maybe an AP class like BC, you can score a 4 or a 5. These are the people that are maybe heading to a school like Mines, even though Mines is going to make you take Calc 1 again. At least you have a strong basis for. So that's kind of like the best of the best. The people that want to make that class probably priority number 1 next year in terms of your workload. And usually that's, if you're a sophomore heading into your junior year and you take Calc BC, the class you'll take senior year then will be AP Statistics. Or if you are the one person in your class, and I mean not this class, I mean the one person in your grade that is the best math student in the grade. Maybe you go on to Calculus 3 after that. And I'm talking about like potential valedictorians that are going to get math degrees or engineering degrees, or going to go to Mines or go to Harvard, Stanford. We've only had, I think, 3 in the last 5 years total. 3 students in the last 5 years total to take Calc 3. Most people will take some form of calculus. So if you're if you're a sophomore right now, going into your junior year, you take calculus because that's kind of the direction you're heading, and then you take AP Stat your senior year. Or if you are just crushing it, I'll throw out a name like Ben Norby. I don't know if you guys know who Ben Norby is. Ben Norby was a freshman in my class and got hundreds. Okay, and then he went to Calc BC and got 95s. right? So you want to feel like math is your thing for sure. A lot of people, instead of going the Calc BC direction, would actually benefit coming down here. I know it says seniors only, but you can do this as a junior for sure. You can take a class like Calc AB your next year after taking Honors Pre-Calc, Calc A, which means that the Calculus A semester that you'll see here this spring that we will start really, really soon, you'll actually see in the fall. Okay, so what happens is calculus is broken into 3 semesters, A, B, and C. And maybe you see all 3 semesters, right? You go Calc A in this spring, then you go B next fall, and then you go C in the spring. Or you see A in this spring right now, and then you see A again. Okay, without the foundation of calculus from Calc A, Calc B is not going to make a whole lot of sense. And we like to have like 2 sections of that. Now, a group like that's going to be in Calc AB are students that are coming from this class that maybe just don't get hundreds on everything, and that's okay. And they want that stronger foundation for calculus, and still could be heading in a math direction, a math type direction, science, engineering, something like that, technology. But know that they're not necessarily going to become mathematicians, right? Maybe that's a direction you're heading in, because that AP class is not going to be nearly as difficult as BC, but it's like Calc 1. Right? It's that Calculus 1 semester that you would see at a college level spread out over 2 full semesters where you're going to see Calc A twice. It might sound like that's too repetitive for you, but calculus is so new to you. It's a whole new language, and you're going to see that in just a couple of weeks. We're going to start building this language together. That people really like seeing that Calc A semester again. They really get a strong foundation, and then Calc B, which is probably, B and C are pretty difficult together, but because Calc B is so different, a lot of people say that that's the hardest one. Although the concepts in Calc C are more advanced than in Calc B, they kind of build from there. So. Calc AB is a great choice for juniors or seniors that maybe just aren't heading in a super mathy direction, but are good at math, that enjoy it, that are going to work for it. It's still an AP class that has AP expectations, right? Now, remember, if you take an AP class, you don't have to pay for and take the AP test at the end of the year. That's kind of up to you. And also remember that any AP class has that weighted GPA bump, that an A is worth a 5 instead of a 4, and a 4 instead of a 3 for a B, and so on down there, okay? So 2 really popular choices coming out of this class would be AB or BC, where the people in BC are the ones that really enjoy this stuff, that want to learn more about the calculus, that really don't need to be pushed to get their work done, and that want to make that basically priority number 1 or maybe number 2, right? But it's got to be up there if you want to be successful, because you will drown if you don't give it the attention that it needs, okay? And I warn you for that to save you from a lot of headaches if you're not ready for it, okay? But an amazing class, okay? Mr. Lynch is the teacher right now, and I think that will stay the same for next year for Calc BC. And he and I are probably most similar. We definitely are different in some of the ways that we teach. But I guess kind of our approach to teaching and our passion for it, I think, is pretty equal. And he knows his stuff. He's been teaching that class a long time. So you're definitely in good hands. Right now, Calc AB is Miss Gibson. And she's super smart. She knows this stuff, again, pretty much backwards and forwards, and can get it to you. She likes things her way. And so if that works for you, then I know that you can be really successful in a class like that as well. The pace is the same. It's just a little bit easier because you're seeing the Calc A again. Okay. AP Stat, great choice. Okay. Probably the easiest, I guess, but not easy of the 3 AP classes that we offer. AP rigor for sure, AP expectations, AP amount of work. And right now it's Mr. Lynch that teaches that, as well as Miss Sigmund. So again, 2 really great teachers that are really passionate about helping kids and are in love with the subject and really know it really well. So I've heard that, you know, the remote aspect of these classes has been tough on students, but hopefully next fall we don't have to deal with that, and that we're all vaccinated and good to go. So, because I think that's what it's going to take to get us back full time. Okay, those are your three choices, really. If math is just not your thing, you don't have to. You don't have to take an AP class next semester. If you've just been kind of good at it forever, and so you've always been on the honors track through middle school and through high school, but maybe you're just, you know, it's just not your cup of tea. That's okay. I would rather you focus your efforts on the things that you're passionate about. This is the time where you can start to switch gears. If you are a senior next year, really the only other choice would be a class like statistical reasoning, okay, which is just more of an introductory level kind of class that just doesn't have that AP expectation, but a lot of the same concepts between those two classes. So if you're a senior, I think stat reasoning is a great place to go. If you're a junior next year, I don't suggest taking stat reasoning because then you have nowhere to go senior year, except like back to calculus, which means taking a year off from calculus and forgetting all that stuff, which I don't recommend. Or taking classes that are lower than the class that we're taking right now, which of course doesn't make any sense. You might not even get credit for it because you're not moving up, you're moving sideways, or you're moving down. Okay, so that's what I've got. That's my little spiel on all that. Hopefully that clears it up a little bit, but I want to field any questions that you have right now that you think are good for the group. If there aren't any, but you have more individual questions, I'm happy to answer those on more individual bases. You can just like stick around the school meet and as everybody logs off, if you don't mind sharing with whoever else is here, because maybe your question is good for everybody. Or we can meet one-on-one, face-to-face during a time like 8th when I'm off, or 1st when I'm off, or during lunch, or we can just kind of chat like emails back and forth or Canvas messages back and forth. I did that with a few people yesterday, which was awesome, and I think it really helped. So questions that anybody has about basically the 4 possibilities for next semester, which is really mostly 3, unless you are just not heading in a math kind of direction, but you still need a math class, so take that stat reasoning. Questions? I tried to get it all out. I wanted to give you as much as I could so that there weren't any leftover questions. Okay, cool. So if you've got an idea for what you think you want to take next semester, fill out that form. Okay, I'd love to get responses early now. Registration isn't until next Wednesday, and we'll talk more about exactly what's going to happen on that day as we get closer to it once I get some direction from Mr. Nicholson and from the department chairs here in the math department. So you know what to expect on Wednesday, January 20th, registration day. But I want you to have your choice basically made before then if we can. So fill out that form. You'll see there's a question at the bottom that says, you know, how much guidance do you need from me? Yes, I definitely want some help, or no, I'm good. This is definitely the right class for me. And then basically one by one, I will sign off on that choice or tell you what I think is best for you. Okay, but if you're good, I'm good, and you guys can head out.